Hi, welcome to TNT Tutoring. Today I'd like to look at some problems that involve the composition of trigonometric functions and their inverses. For example, a problem like this, sine inverse of sine of x equals x, where we need to find the possible values that x could take on. But before we get into these problems, I would like to take a moment to look at the graph of y equals sine of x, also come up with the graph of its inverse, and state the domain and range for those two functions in addition to the cosine and tangent and their inverses. So let's see, if we start off with sine, you know that the sine curve continues to oscillate back and forth indefinitely, and its domain is all real numbers. However, if you take notice how I've done this in the graph, I've went ahead and I've really highlighted the graph of sine of x from negative pi over 2 to pi over 2. And the reason we'd want to do that, okay, make our domain from negative pi over 2 to positive pi over 2, is because when we come up with the inverse, it would allow us to create a function. If there's no restriction on the domain of sine of x, when you go to create its inverse, the inverse would not be a function. Okay, and we'll talk about how you do that in just a moment. Alright, also, if you notice, the range in that restricted portion of y equals sine of x would have a range of negative 1 to positive 1, just like it would if it had no restrictions on the domain. Now, if you recall, by definition, to form the inverse of a function, you have to switch its domain and range. So all the x's become y's and all the y's become x's. So what that means for us is that the domain of sine inverse of x would be the range of sine of x, or in other words, negative 1 is less than or equal to x, which is less than or equal to positive 1. And the range of the inverse would be the domain of y equals sine of x. So that would be y values that are in between negative pi over 2 and positive pi over 2. Okay, so if you're a very visual person, it might help you to look at some of the points here. And recall that when you form the inverse, you're just flip-flopping the x and y's, the domain and the range. So on the original graph, y equals sine of x, you have the point pi over 2 comma 1. So on the inverse, you should have 1 comma pi over 2. And if you had negative pi over 2 comma negative 1, you should have negative 1 comma negative pi over 2, which would be about right here. So you'll have a graph. It's not very nice looking, but you should have a graph that looks something like that for y equals sine inverse of x. Okay, now we could take a similar approach for the cosine function, also for the tangent function, and come up with restrictions on its domain range. But for time's sake, I'm going to go ahead and just fill those in for you. Okay, the domain, the restriction on the domain of cosine x is that we're going to look at it from values of x that are between 0 and pi. Its range, just like the unrestricted, sorry about that, would be y values between negative 1 and 1. So if we want to find the domain, the range for the inverse of cosine, remember, we're just going to flip-flop the domain and range. So the domain would be x values between negative 1 and 1, and the range would be y values between 0 and pi. All right, let's see. Tangent. The domain for the tangent function, well, if you recall, the parent graph has vertical asymptotes every pi over 2, at positive pi over 2 and negative pi over 2. So the domain here that we're going to restrict ourselves to is just one period of pi, or one period of tangent, which would be from negative pi over 2 to positive pi over 2. The range of that, okay, if you remember, as it approaches the asymptotes from the left and from the right, we're going to head towards negative infinity and also positive infinity. All right, so when we switch these around, okay, the domain for the inverse of tangent would be negative infinity to infinity, and its range would span from negative pi over 2 to positive pi over 2. All right. Now, before we get into answering these questions, one more thing. Over here to the side, I've put a unit circle, and I've marked a couple key points. At the bottom of the circle, we have negative pi over 2. To the right, we have 0. At the top, positive pi over 2. And to the far left here, we have pi. And it might be helpful to color code the circle so you can also see another way of representing some of the restrictions on these inverse trig functions. So, how do we highlight it? Let's see. All right. I'm going to highlight this in purple. All right. Any of the values from negative pi over 2 to positive pi over 2 would apply to sine inverse, and they would also apply to the tangent inverse. And I think we can see that up here, right? The range was from negative pi over 2 to positive pi over 2, and the same was true for the tangent. Also, if you look at pi to 0, right, that corresponds to the range of the inverse, or the domain of cosine. So put cosine inverse there. Okay. All right, now that we've looked at sine, cosine, tangent, and their inverses, and found their domains and ranges, let's take a look at a couple of the problems that we have over here. Okay. First problem says sine inverse of sine of x equals x. And we have to fill in the blanks here for what the possible values of x are. So here's what we need to think about. If we were evaluating the sine of x, right, and we're plugging a number into there, or I'm sorry, an angle into there, we're going to get a number out. So what does that actually mean? Well, think about it. The input to sine, right, we said would be angles from negative pi over 2 to positive pi over 2. And the output would be a value of y from negative 1 to 1. But remember, the output for this sine of x is the input for sine inverse. Okay, so think about the progression here, right? We have an input from negative pi over 2 to positive pi over 2, which gives us something from negative 1 to 1, right? Same thing here. And that input from negative 1 to 1 gives us an output in the range from negative pi over 2 to positive pi over 2. All right, so why am I pointing this out? Well, if you're doing a composition and the outer function is sine inverse, cosine inverse, or tangent inverse, okay, the final answer has to be an angle. So, if you think about that, we're starting with negative pi over 2 to positive pi over 2. We're putting it into sine of x, getting something from negative 1 to 1, and when we plug that back into the inverse, we get back to where we started from. So the answer for this would have to be x values from negative pi over 2 to positive pi over 2. All right. Now if you look at example B, you can see these have been reversed. Sine inverse accepts numeric values and puts in outputs an angle. Then when you take the sine of that angle, it gets you back to the numeric value. So let's go back over here and go through this flowchart again. Okay. The domain for sine inverse are numeric values right here. Okay. The output is an angle between negative pi over 2 to 2. Remember, the output for the sine inverse is really our input for the domain, or for the input for the sine inverse, or for the regular sine, sorry. And its output gets you back to a numeric value. All right. Or another way to think about it is if the outer function is sine, cosine, or tangent, okay, the final output should be a numeric value, not an angle. So the values of x will be from -1 to 1. All right. That's going to be a similar approach here when we look at example C. If we're looking at cosine inverse as your outer function, we know that we're looking for angles. Okay. What angles correspond to cosine inverse? Well, put it over here in the circle, or you could come over here and you could look at the range, right? The output from that. You would get 0 to pi. All right, let's flip it around. Example D. If you're taking the cosine of something, you should end up with numeric values. Well, what numeric values does cosine always produce? Well, it produces outputs from -1 to 1. All right, let's switch up and go to tangent now. Tangent, right? I'm taking the tangent of some number or some angle, so I should have numeric values, okay, for B. So let's go over and look at tangent. What do we have here? Well, tangent, we know if we put in any kind of angle from -pi/2 to +pi/2, the output has to be from -infinity to +infinity. And if we're dealing with tangent inverse, well, tangent inverse takes values from -infinity to infinity and has outputs, okay, that are angles, right, from -pi/2 to +pi/2. I hope you've enjoyed this tutorial. Thank you for visiting TNT Tutoring.